All right, so now we're going to get into some of the actual naming of these compounds now, okay? So first up, we have MgCl2, okay? So for the most part, if it looks like an I and it's after a C, it's a Cl, it's not Ci, okay? So it's MgCl2. So first thing you need to do is figure out what Mg and Cl are, okay? So if you look at a periodic table, you will see that Mg is magnesium. Let me see if I can write with my finger here. Okay, and then Cl is chlorine. Okay, but remember this is an ionic compound, so we have to change the ending of the second word here. We have to change the ending of the chlorine. Okay, so we have to change that to chloride. Sorry, if you can hear Potter running around, he's kind of antsy right now for some reason, but so you have chlorine, okay? You need to change the ending to IDE. So knock off the INE and it becomes IDE. So this is magnesium chloride, okay? Notice we don't have any Roman numerals here because magnesium is in one of the first two columns on the periodic table, so it's not part of the transition metals which come after those first two columns. Okay, and then you also don't have to say how many chlorine atoms you have. Okay, because if you look at the periodic table, you will see that magnesium is in the second column. That means that magnesium has a +2 charge on it. Okay, so you have Mg, which is a 2+, okay? And then if you look at the chlorine, you will see that it's the second column from the right. Everything in that second column has a -1 charge on it, okay? So then you basically just have to do simple math here. You've got magnesium, which is a 2, plus your -1, but it has to equal 0. Okay, so at this point, you add those two together, 2 plus -1, you're going to get a 1. Okay, so in order to make this equal 0, you just have to multiply your -1 charge by 2. Okay, so you get 2 chlorines to every 1 magnesium, which is how you get your MgCl2. Okay? All right, next one. So we have lithium, and now we have a polyatomic ion added in. All right? So you find lithium on the periodic table, your Li. So you have lithium. Okay. Now, what polyatomic ion is that? That one, hopefully you have your note cards. That one is nitrate. Okay, there. Lithium nitrate. Now, because that is a polyatomic ion, give me one sec, let me yell at my dog again. Okay, so because that is a polyatomic ion, you don't have to change the name at all. Okay, it's just whatever the name of the polyatomic ion is. Because if you started changing that name, then you would end up with some really funky stuff going on. Now, note here, you have LiNO3, okay? If you called this lithium nitride, okay, the IDE ending means that it's just nitrogen, okay? Now your lithium has a +1 charge, okay? So it's Li+, all right? Now your nitrogen has a -3 charge, okay? Which means that you would have to have 3 lithiums. So if you had lithium nitride, that would be Li3N. So you see how this formula is different from this one over here. Yeah? Okay. So that's why it's really important to recognize the endings on these words. Okay? The cations are always relatively easy because they tell you exactly what it is. Okay? There's not a whole lot of difference there. Usually they just come straight off the periodic table. It's just the ending on your anion where things get a little bit tricky. Okay, so this one is lithium nitrate versus lithium nitride. Okay. All right, so now we're moving on. We've got HgCN. Okay, so Hg is mercury. Let me actually get a little bit more space here. No, come on. There we go. All right, so we have mercury. Okay, but one thing you'll notice is mercury is in that middle section of the periodic table, the section that kind of looks like it's out of place a little bit. Okay, so that makes it a transition metal. So we are actually going to have to put in a Roman numeral for this. Okay, any element that you see in your compound that is from the transition metals has to have a Roman numeral. Okay, and remember the Roman numeral tells you what charge is on that atom. Okay, it doesn't tell you how many there are, just tells you what the charge is. Okay, then we have Cn. So you see that Cn, you've got 2 atoms, so it is a polyatomic ion. So that one is cyanide. And cyanide has a -1 charge on it. Okay, so you have your Hg, which has an unknown charge on it. Okay, that is supposed to be a question mark. And then you have your cyanide, which has a negative charge on it. Okay, and it needs to equal 0. Now what you'll notice from this formula here is that you have one of each. So you have 1 mercury, you have 1 cyanide. Okay, so you have a -1 on your cyanide. You don't know what's on your mercury, but it has to equal 0. So your mercury has to equal +1. Okay, which means that you just put a single I in that parentheses. I means 1 in Roman numerals. So it's mercury 1 cyanide. Okay, now obviously I didn't write that there, so that should be a 1 right there. Mercury 1 cyanide in parentheses. All right, moving on to the next slide of these. So now it's going to get a little bit more complicated. Okay, so first up, identify your cation. So what does Na stand for? Well, if you look at your periodic table, you'll see that it is sodium. Okay, and then if we go over here, we'll see that each sodium has a +1 charge on it, and we have 2 of those. So we have a total +2 charge at the moment. Now we still need to add in our anion, and then it has to equal 0. Okay, now we have a polyatomic ion for our anion. So again, all you do is just write the name of your polyatomic ion. So this one is carbonate. And what you'll see if you use your note cards and look at your carbonate, that one has a -2 charge on it. So this compound is completely balanced. You have +1, -2, that equals 0. So sodium carbonate is the name of this ionic compound. Moving on. Okay, so now this one is a little bit different. We have a cation as our polyatomic ion is a cation. Okay, so if you remember, this one is ammonium. Excuse me if I spell this wrong. I always get messed up on how many M's are in this word. Okay, now we have just an N. Okay, remember the N on its own is not a polyatomic ion. So we now need to go to our periodic table to figure out what N is. And it is nitrogen. Okay, but this compound is not ammonium nitrogen, right? Because remember, we have to change the ending on our anion. So nitrogen becomes nitride. So it's ammonium nitride. Now each ammonium has a +1 charge on it. Each nitrogen, nitride in this case, has a -3. So with our 3 ammoniums, okay, each with a +1 charge, we have a balanced formula. And I actually spelled that right. It's minor miracle. All right, last one of this style, and then we're going to go to the next video to basically do this backwards, okay? So we have K3P, all right? So K, believe it or not, is potassium, okay? Each potassium has a +1 charge, and we have 3 of those, okay? And then remember, we still have to equal 0, and we have our P, which is phosphorus. Okay, now each P has a -3 charge, so that balances there, okay? And now we need to change our ending of the anion, so it's not phosphorus, it's phosphide. So it is potassium phosphide. All right, so we're going to break here in this video and then continue on naming ionic compounds going backwards, starting with the name of the compound and then writing out the formula from that in the next video.